topic, we're going to be talking about the modern analytics and governance at scale. This is the Microsoft's hybrid approach to data mesh and data fabric. So our goal is how are we going to take the cloud adoption framework, the cloud scale analytics framework, and build a specific framework, if you will, for data mesh and data fabric. Firstly, I would like to be very clear in regards to the Microsoft's position when it comes to data fabric or data mesh. Number one, Microsoft is focusing on the organization's challenges, their strategic vision, as opposed to a framework, build a framework and land it to the client. What we have here is a composable solution, and I'm gonna go deeper into this a bit later. But our goal is focus on the specific needs of the clients, and then we'll land some of this composable or components of the bigger solution. Number two is Microsoft would like to provide the North Star of implementing modern analytics ecosystem, which is the technology, and how do we align the people and the processes. So a lot of our conversations with our clients, from CDOs, VP of data to the director of analytics to the architects, they're asking about, hey, you know what? I have these silos of different solutions. I have a data warehouse. I have a lakehouse. I have IoT solutions over here. But our challenge is how we're going to make all of these solutions unified. How we're going to operate the end-to-end data and analytics operations from the time we ingest the data all the way to federating this data to the different lines of businesses so that they can use this for their projects, right? So our goal is to provide that North Star. And what we did is take a lot of our implementations internally from Microsoft. We have a team in Microsoft Digital, who is actually working on our digital transformation that is related to data. So if you think about it, Microsoft is one of the biggest clients of Azure. We have a lot of data coming from Bing, coming from Xbox, coming from Azure. Imagine the amount of data we're generating by running Azure itself. So we took a lot of that implementation and we went through a lot of this, a lot of these iterations and journey. And what is the solution that we're using now is what we're sharing. On top of that, we are also working with a lot of organizations, a lot of our clients that have already implemented data mesh and data fabric. And so we would like to share that with you as well. So what we are sharing as part of that North Star is the combination of these implementations so that you don't have to think about, how should I do this? We can give you guidelines, we can give you the best practices, and the goal is to kind of provide it in here. There's a lot of content for this very specific topic, and I'm trying to kind of just compact it for 20 minutes. But I'm looking forward to connect with you and how we can, go deeper and understand how we're doing this with Microsoft. The third one is we support aspects of data mesh and data fabric, but we would like to be cautious that we are not purists in either of this framework. So I would like to give, I would like to give kudos to Zamak Digani for the thought leadership on data mesh, our partners and organizations who are implementing data fabric. And this gives us the opportunity on how we're going to be able to use your kind of leaderships in these areas, make it more kind of like applicable for our clients. And hopefully this aligns according to your definition of this too. So I know Didem earlier discussed about the challenges from the different organizations. I'm not going to go deeper into what we've heard right now, given that she already covered that. But I would like to highlight 2 or 3 things around this, what we've heard with our clients. Earlier, I discussed about clients, CDOs, VP and data, directors, what have you. They're looking for ways on how do we build the data and analytics foundation and operationalization. We are in a business that we are now operating data as a data product. We're from raw data to a data product. So how do we do that? How do we make sure that the infrastructure is there to support our needs? Number 2 is data governance. We've started all this kind of like amazing kind of like vision when it comes to machine learning, AI, would like to build all these insights. And we have clients, unfortunately, that went through the kind of like the goal in building the project, but 6 months down the road, they realize, hey, you know what? We're not able to be successful in this project because A, the data is dirty. B, data is not integrating. There's a lot of data that we need to go through to find the right data for this project. So data governance is really, really important. The other thing that also didn't mention is the cost of data engineering. Over the whole cycle of this implementation, 70 to 80% of this is ingestion and engineering. And our clients are asking, how can we make it easier so that the data agility improves? How do we kind of like enable the lines of businesses? We'd have to go into this tedious job of ingestion and data engineering. And so with that, I would like to proceed to the next one. So I'll start with a traditional implementation and how we're going to evolve to a data mesh. So if we have already implemented modern data warehouse or have done, say, data warehouse or Hadoop migration, you probably are looking at this kind of like, conceptual architecture. Data gets in through ADF, landed in the data lake, start cleaning the data using Spark, and then hosting that data into a data warehouse, and then the reports will consume them. If you think about it, a lot of our clients are saying, hey, you know what, this is the monolithic approach. Our challenge right now is the central team, the shared services team, or the data office team. We are trying to kind of build all these projects for the different lines of businesses. The big challenge that we have is we are not the experts when it comes to building these reports or machine learning models, what have you. They are the experts. So just the handshake of kind of like transferring the knowledge from the lines of businesses to the shared service is a big challenge. It takes months, if you will, right? And also think about how we're implementing these different projects. Think about a data warehouse, just one data warehouse trying to kind of cram all these projects, and how do you orchestrate all these projects so that one is not going to affect or cause any problems to the other. So a lot of our clients saying, hey, you know what, we need to kind of empower our lines of businesses. We need to kind of enable them so that they can build their own dashboards and reports. They have data scientists, they know about this data. We need to enable them so that they can build their own machine learning. So what we're trying to do with a lot of our clients is how do we evolve them from this monolithic kind of implementation to a federated one? So if you think about it, the existing implementation, we can take it as a shared service domain. You don't have to rip and replace anything that you've built. Your lakehouse is the foundation, and that is the move forward. 100% keep that, continue on with the lakehouse approach. In terms of the ingestion and data bricks, some of these are manually done. Some would have the metadata ingestion framework, but still not enough. So how can we automate some of this? I'm going to go deeper in a little bit. So coming from this shared services kind of mindset, how can we start federating this so that we can start building the different domains for the different lines of businesses? So as an example, you can start. You can still keep the shared services here, but you can start enabling your marketing, for example, marketing line of business. Usually they have their own data engineers, they have their own data scientists, they have very agile kind of approach in kind of like deploying their insights. Some of them are ad hoc as well because they need to be kind of like very advanced in terms of how they're approaching a lot of these data products, if you will. So we can start building these domains. I'm going to go deeper into this a bit later. Keep the data inside your central data storage and keep tenants, tenants per domain so that you can, or the different lines of businesses can have their own tenant storage where they can start building their data products. So if we're going to go deeper into what we're trying to provide here is we are creating different domains for different lines of businesses. The different lines of businesses then can start kind of building our data products. These are projects that are related to dashboards and report, machine learning, operational data hubs, IoT, and analytics. But in the middle, if you notice here, governance is at the heart of all of this. The automated services is also a part of this, and also the Polyglot data store. I'm going to go deeper into this a bit later, but what I would like to show here is if you look at the four principle of data mesh. Number one is the domain data-driven ownership. So as you can see, we're federating the ownership of data across the different lines of businesses. And number two is self-serve infrastructure as a platform. How we're moving forward with these domains is we are recommending templates. As a matter of fact, we have available templates right now that you can start with. So you can build, a domain with all the networking components, with all the security requirements, monitoring, what have you, and that's part of that. So by doing this, we're actually enabling self-serve analytics on the infrastructure side. I'm going to talk more about the ingestion side, the data side, self-serve data side a bit later, but that's the component that we have here. Data as a product, this is where the different lines of business are going to be building their own insights and start kind of sharing some of this data product across the different domains. And then the other one is the federated computational governance. So this one comes in two components. One is data governance, which, related to the data cataloging, classification, lineage. But the second part of that is about the governance when it comes to providing policy on how we're going to keep the data, how we're going to kind of implement the different domains, the integration points, the networking, the security, and all of that. So with that, I'm going to go deeper into one of the components, which is the enterprise data governance. Regardless of data mesh, data fabric, data warehouse, what have you, very foundational is enterprise data governance. We have Azure Purview right now, and there's a lot more features coming out of Azure Purview. But why we need this? We need to automate the scanning of your environment, maybe on-premise in Azure or third-party cloud. We need to make sure that you have the information by building this catalog automatically after you scan that data. And then now you have understanding about the metadata that you have per data set. You can start looking at the lineage once you have built that map and that catalog. You will have data owners for that, descriptions about the data sets, the columns, what have you. One important thing that is very, very critical is the data classification. We have conversations with a lot of our clients, and when we ask how many confidential data that you know, and the answer is I know what I know, but because we have so much data, it is hard for us to say that we have confidential data out there that we are not aware. So by using the automated data classification, you are removing that risk of finding those specific confidential data. And we are working with a lot of our partners as well because they have classifications capabilities that we can augment and add more if you need more, more customized classification. We have in Purview our own custom classification as well. So that is an accelerator, an enabler for you to make sure that you're classifying your data properly. Why classification is important? It's aligned to the data policy because once you know your data is confidential, you can apply the data policy so that every single confidential data will be kind of like masked or kind of reduce the security only to the data owner. So that policy will automate all that data management, making sure that you are not exposing your confidential data to the public or to people who do not need access to them. The last one that I would like to mention here is the data use governance. If you're thinking about data mesh or data fabric, you need to enable the data use governance. Meaning, me as a line of business, if I need to actually have access to the data, I'm looking at the data catalog, I see the metadata, I see the lineage, and I need this data, but I don't have access to it. With the data use governance, I can request access directly if that data is in Azure now. You can access to that. It will go through the queue. The data owner will approve it. And once you have that's approved, then you have access to that data and you can start with the exploration or use that data for your insights that you would like to build. Moving on, just checking time here. The automated in data analytics operations. This is an IP that we took from Microsoft Digital Transformation. And a lot of this too is working with our partners on how we can enable some of these automated data and analytics operations. So the goal here is to have an operations console. How do we, say, for example, onboard a new line of business? Say you have a new project and it's a domain on its own. Say you purchase a new company and it's a domain on its by through the operations console, you can onboard the new lines of businesses. And because all these domains are based on templates, and you can pick the services that you need, you will be able to onboard this lines of business very, very quickly. So the next one is data products onboarding or data source onboarding. Say, for example, we have new projects, we got data that is not in Azure yet. You can onboard your data coming from, say, Oracle on-prem or SQL Server on-prem. So coming from the data catalog, you can take the metadata and then the data sources. And then from them, you can ingest or kind of input that to your metadata-driven ingestion so that now this data will start flowing from on-prem to Azure. Why this is important is because if you are serving analytics from your operational databases on-prem, a lot of the feedback that we're getting from our clients is we're not going to allow that because already our performance is not there, and to put analytics on top of it is a big problem. Number two is security. We cannot just allow multiple analytic scenarios for our operational environment. The governance is much easier if you kind of take it from an analytics environment. So that's number one. So going to the process then, how do we accelerate that data engineering is now by enabling the data standardization automatically. For example, data is coming as a CSV, TSV, you can start converting it to a Delta. which is our recommendation right now. And the next one is apply light data quality. There are data out there that are like duplicated. Start removing the duplicates. Start aligning the different time zone. Check if the data is within the threshold, as an example. So those are light data quality work that will speed up data engineering so that you don't have to kind of tediously put it in your code every single time you need to clean that data. Next one is the metadata registration, meaning as the data is now onboarded in Azure, you can start pushing that data into the catalog so that's immediately available for other users or other domains to kind of discover your data. And then last one is access provisioning, because you requested to have access to this data, you will have access to it. You can also add specific Azure Active Directory groups to have access to this very specific data. So if you think about it, by automating a lot of this, light data engineering work, the goal is now how do we kind of ingest and data engineer at scale to meet that data agility that you're looking for. So with that, then data is now flowing. It's getting into the Polyglot data store. I'm just going to touch upon this very, very quickly. A lot of data is coming into the data lake, structured data, unstructured data, but there's a lot of data that is coming from on-prem as well. There's a lot of operational databases, for example, data marts that are just being migrated from, say, SQL Server on-prem to Azure SQL databases. Those data is still your data, and we don't really recommend you to kind of migrate that data into the data lake. Keep it where it is because that's your operational data. You might be modernizing your applications and what have you. You might have an IoT solution where you're using NoSQL database or Cosmos database. You need this to be as part of your Polyglot data store. So all this data you can share to the different domains. So as we are picking data, say, for example, data coming from the shared services here, and then going into combining it with the marketing data, and then now you can build a data product. And you can build multiple products from this different tenant storage within that Polyglot data store. Now, coming into the different domains, right? These are the domains that we're talking about. How should we architect for it? So the common challenge that we're hearing from clients is building this Lego blocks of services is just too complex for us. Think about the security. Think about the integration points. Think about the seven enterprise requirements that we need to be able to architect for this specific line of business. So we heard you. Our clients are saying there should be a better way to do this, and we heard you, and that's why we built Synapse, Azure Synapse Analytics. Azure Synapse Analytics is an ecosystem where you have orchestration and integration. Orchestration and integration here is actually the same code base as we have with Azure Data Factory. So this is not something new that we just built. This is just something new that we packaged together for you so that you don't have to. So all of that Azure Data Factory capabilities are here. Management of the pipelines, the clusters, monitoring them is also part of the whole ecosystem. But one thing that I would like to kind of drill a bit deeper is what are the different engines that we have in Synapse? So Synapse is not just a data warehouse. It's a very small portion of what we are delivering. It's a data warehouse, but with machine learning. A traditional data warehouse that you will find in the market, you will have to pull the data out of the data warehouse to be able to do machine learning, put in the lake. That's a big challenge for our clients, big banks, healthcare, what have you. There's terabytes and petabytes of data, and imagine pulling that data from the data warehouse just to do machine learning. So rather than doing that, we bring you the machine learning code so you can start scoring your data that is inside the data warehouse. Spark, so by the way, SQL Data Warehouse is not new in Synapse. This started from way back PDW, the SQL Data Warehouse. This is years and years already. We just put this in one ecosystem, so this is not new. Spark deployment, this is the open source Spark. This is also nothing new. This is by the community who actually contributed to Spark. We are contributing heavily on this as well, and this enables you to have data engineering and machine learning. Next one is the serverless capabilities. This is now giving you the capability, if you have the data in the lake, it'd be like TSB, Parquet, what have you, giving you the capability to start exploring that data without having to build tables, without having to kind of prepare the table before you can do just exploration. So this is a serverless capability where you can write SQL on top of your data inside SQL. And then the last one that we have here is Azure Data Explorer. Again, this is a standalone service that we had, Azure Data Explorer. We're using it in Azure to monitor our logs, what have you. So this is a capability that we tied inside Synapse so that all the time series needs that you have, IoT, if you want to do real-time or digital twin capabilities, this is the data store that will serve that data to you very, very quickly. Integration points, this is the important one that I would like to mention, because now within the Synapse, it's tightly integrated with the data governance. So from within Synapse, you can start to look for data, the business glossary, the data catalog, for example. Data sharing is one important one that a lot of our clients are leveraging right now. Why this is important is if you have a data in a data warehouse, you can share that data and land it into a third-party provider, like for optimization, what have you, or other purposes. But you can land it in the receiver's data lake. This is not a proprietary, like it has to be a data warehouse. No, this is flexible because you can land this data in a data lake somewhere else, in a subscription, in a domain, so on and so forth. Machine learning is our hub for machine learning capabilities. We have tight integration with there so that all the models that we have actually implemented there or kind of built there, we can score and deploy into the machine learning that we have in data warehouse. Lastly is dashboards and reports. You can start building reports, dashboards, what have you, from within Synapse. So with all that said, all I can say is we try to simplify the implementation of your analytics environment. By doing this, you don't have to stitch all the different services, and gives you the capability and agility to kind of enable the different lines of businesses so that they can do their own analytics. And so how do we align to the data mesh? If you look at the literature from data mesh, there's 3 planes. There's the mesh experience plane, which equates to the data governance that we were talking about. There is the data products plane that talks about how do we create, how do we read the version, the security of that data. We include that in our data operations, and we automated it as well. The next one is the utility plane. How do you make sure that the networking is proper, the CI/CD, the access control, and data transformation? This is what we put inside our domain. We have templates, and we made it a lot simpler as well with Synapse on how you're deploying this analytics environment. And so with that, I'm going to pass it over to Espen and Pithine on how you can apply this and build a data mesh in your organization.